what are all these? What do they mean? What's marginal? What's differential? What's linearization? There are three different concepts. 1, 2, and 3. I will present differentials first, because after we present differentials, we will be able to understand the marginals. The concept of the marginals really refers to a derivative. So I can mention that first, and then we'll talk about differentials. And then we'll come back to marginals. So when we say marginal cost, we really mean C prime of x. When we talk about marginal profit, we really talk about P prime. We talk a marginal revenue, we really like to call this, and we say R prime of x. So why do we even talk about this? Well, these are just, I would say initially, for now, I would say these are the names. C prime is normally called marginal cost, P prime marginal profit, and so on and so forth. But all this theory comes from differentials. So what is a differential? Okay, there is some explanation behind it, so please bear with me. Try to pay attention, because this will be very clear if you pay attention, please. And please ask any question anytime. So let's take a look at the function. So let's say this is function f of x. I'm going to choose a point on this function. We've done this idea before. So I'm going to call this point P. I'm going to say that the x-coordinate is x. Can anyone give us, it's a point on the graph, can anyone give us the y-coordinate? What do you think the y-coordinate is? We've done this before. What can it be? It's a point on the graph. If this is 5, what will this be? If this is 10, what will this be? What do you think? I know everyone knows. If this is 5, what could this one be? How do you determine it?
Would it be 5?
I'm sorry?
Would it be 5?
But I don't know. So this is the function. If I say here on the side, the function is x plus 1, and I say x is 5, how do you determine the y value?
You would substitute the 5 in.
Absolutely. So this must be f of x, no question. That's it. That's all I need you to say. If this is x, this must be f of x. Perfect. So let's say now that I have a point Q, but Q is very close to P. So Q is somewhere here. But if I put it here, I'm not going to be able to explain. So assuming that we zoom in, but Q is very close to P. The coordinate, the x-coordinate of Q is x plus a little bit. The little bit in the past was little h, and we had the difference quotient. This time we're going to denote it by dx also delta x. So this symbol is the Greek letter, uppercase letter, delta. So here I have either x plus dx because they are the same, or x plus delta x. Can anyone give us the y-coordinate of Q?
Is it f of x plus delta of?
It doesn't matter which one. Of course, I'm going to write both just to make sure that this is clear. F of x plus delta x. It doesn't matter. Absolutely. So this is, you can call it f of x plus dx, or you can call it f of x plus delta x. They have to be the same because dx and delta x are the same. Okay. So I'm sure you're asking yourselves, what are you trying to say here? Okay, so here's what I'm trying to say. I didn't get there yet, but this is the heads up. Let's say we are manufacturing discs for whatever reason, whatever product you want, but it's a disc. And the radius of each disc, for simplicity, I'm going to say it should be 1 inch. So we produce these discs and we have quality control, and they take several of them and they measure and they say, oops, well, it's not 1 inch. It has 1.1 or it has 0.9 inch of an inch, but it's not 1 inch. Uh-oh. Well, it means that I have an error. What is the error here? 0.1. What is the error here? Negative 0.1. So this is what I'm telling you here. Q is very close here, and this is an error. It's not x. It's x plus a little bit or minus a little bit. It could be on this side, right? So, but what is the major issue? The major issue is that this error in x creates an error in y. So let's say for our discussion here, the area is the function. But if I have a small error in the radius, of course I will have an error in the area. So if I have a small error in x, that will trigger an error in the area, in the function. So delta x dx are the same. So this is the exact error, if you want to call it error, or deviation from x, the exact error in x. These are the same, but this is called, because it's it's d, not delta, dx, this is called the differential of x. It has something to do with the derivative. That's why the diff here. It's a difference, but using the derivative, differential. This is the exact error. They are the same, but they will not be the same in y. So, what do you think delta y will represent? What will be the meaning of delta y? And then we'll write it. So this is delta x that triggers delta y. This is my delta y. This will be the exact error in the function. And delta y, can anyone try to tell us what is delta y equal to? What do you think? Think in terms of finding the slope of this, the same idea. We're not finding the slope, but what I'm saying is, think in those terms. How will you determine the rise?
Is that the rate of change?
We're not doing that, but I just need the rise. What will be the rise of this slope, of this line? It's y2 minus y1, right? right? y2 minus y1. So how do I determine the slope of this? y2 minus y1 over x2 minus x1. I'm not determining the slope. I just want the exact error. So this is f of x plus delta x minus f of x. y2, this piece, minus y1 will be the error that it was created by an error in x, and it gave us an error in y. Good. Of course, now you know what I'm going to do next, I'm sure. I'm going to draw a tangent. Of course. So far, there was no calculus. Good. Now we're talking about calculus. We're going to draw the tangent to the graph. We're going to extend this. We're going to extend this vertical line. We're going to extend this line. And we're going to see here a right triangle. We know this piece. It's dx. We're going to talk about this piece in a minute, but not before I emphasize that this difference, again, what is this? What is this difference? How do we call it? What should I put here next to this piece?
Delta y.
Excellent. That is exactly delta y. Perfect. Awesome. I'm going to take this triangle out of here for a moment because I need to explain something, and then we'll come back. We'll come back to that graph in a minute. Okay, so here was our graph. We had P here. This was the tangent. We had here dx. Since this is the tangent to the graph at P, and this was x, can anyone give us the slope of the tangent? Now thinking in terms of calculus. What is the slope of the tangent at P equal to, from what we studied so far in this class? It's okay if you're wrong, just give it a shot. So again, I have a graph, I have a point, and I want to determine the slope of the tangent, and this is a function, and this is 5, and I want to determine the slope of the tangent when x is 5. How do I determine this from what I know so far in this class? And this is not algebra, but this is calculus. How did we determine that slope of the tangent? We did it many times, and we also determined the equation of the tangent line. We did it many times. How did we determine the slope of this line? Anyone remembers how we determined the slope of the tangent line? And the example says?
Derivative.
Yes. Yes. F prime of?
The slope. Or 5.
Exactly. It has to be at this point. Awesome. So then coming back here, what is the slope of the tangent line at the point P? By comparison to what we just refreshed our memory on, what will that equal to?
Derivative of x.
Excellent, because this is x. Exactly, thank you so much. Excellent. Okay, perfect. So I know that the slope of this line is f prime of x. I know that this piece is dx. I am after this piece. What could this be? Before you say anything, we know that in a triangle like this, the slope of this line, which is the tangent, is not only f prime of x, but also rise over run. I know the run. I want someone to help us determine what could the rise be, denoted by. And we had this notation many times. What do you think this could be? From what you've seen so far.
That'd be d of y.
Yes! Thank you. Very good. dy indeed. We know the notation. F prime of x is dy over dx. It cannot be anything else. Brilliant. So I never told you till today. I only said this is one entity. Don't separate them. But now I'm showing you that each piece has a meaning. So f prime of x is dy over dx, and this piece, can you solve this equation for me for dy? I want from here to find dy, and then I will tell you that this is the differential of y, or the function. Can anyone solve this equation for us for dy? How much is dy?
Would that be f prime of x multiplied by dx?
Brilliant, that's it. Okay, so again, you're saying, what are you talking about? Okay, here's what I'm talking about. We identified that this is the exact difference created by this error in the function. But now I'm telling you that this piece, because that's what I have here, this piece is dy. One more time, because this is the final question, and then I'll show you how we use this concept. I would like to get a relationship between dy and delta y, and before you tell me what it is, I have to refresh your memory and tell you that q is basically here. Not here. I zoomed in so I can explain. So I would like you to come up with a relationship that you think between delta y and dy. So this is the exact. This is obtained with a derivative. This is not obtained with a derivative. How come that this is obtained with a derivative? Because I used the slope of the tangent. So this piece is determined with a f prime. This is not. This is simply plugging in the function. Q is right here. And I want a relationship between these two quantities. What do you think?
I'm guessing one is the zero of the other.
No.
Like we did.
So I'll give you some hints. I want a symbol from here to be put here. What do you think? Wild guess.